we were discussing about balanced forces and unbalanced forces, and we tried to create some questions based on that. Now, let's go to the next thing. Let's look at a couple of other, we'll look at that a little later. I'll say second law. Of course, it is not exclusively defined in your syllabus, but the outcome of second law is given to you. Now, first law, what does first law talk about? If you see, first law talked about if net external force acting on a body is not equal to, is equal to 0, then what is change in delta V means change in velocity. Change in velocity is 0. That was the basic idea of first law. And that law is also called law of inertia, right? So first law gives us an idea about the state of motion of the body before force is applied. Now, if a force is applied on a body, what will happen? If force is applied on a body, what will happen? What might happen? We've seen what all things can happen.
It'll go forward or backward. It'll move.
Yeah. So all the things that we have discussed, right? If it is an unbalanced force, then what will happen? If I'll just change this. What does second law says? F net. If F net is not equal to 0, delta V is not equal to 0. So what is the meaning of second law? First law is what? If no external force acts on the body, the net change in velocity of the body is 0. If external force acts in the body, there is a change in velocity. Now, how much if there is a change in velocity? If you remember, what is acceleration? Acceleration is what? Change in velocity by time. So acceleration, we write it as final velocity minus initial velocity by time. This is how we write acceleration, right? So if there is change in velocity, what will happen? There would be an acceleration. Now, if I want to find out how much is the force, I can say net force is directly proportional to acceleration and net force is directly proportional to mass. I can write F is proportional to mass and acceleration, or I can write F equal to some constant into mass into acceleration. Now, this constant is constant of proportionality, which is equal to 1. So from this, what do we get? We get F equal to ma. A common statement that you might have heard many times, F equal to ma. That's what is Newton's second law. So, let's try to analyze this once again. First thing, what does second law tell us about? Now, second law tells us about the state of the body when the body is in motion. When a force is applied on it. So when a force or when a net non-zero force is applied on a body, what happens? There is change in velocity. If there is change in velocity, what will happen? There would be acceleration, right? So whenever a net non-zero force acts on a body, there is an acceleration produced in the body. And the force acting on the body is directly proportional to acceleration, and it is also proportional to mass. That means what? If I have to produce more acceleration, I have to apply more force. Similarly, if I have to produce more, I have to move more mass, I have to apply more force. So taking both of them into consideration, what do I end up? I end up getting force equal to mass into acceleration. I hope this is clear to all of you. Is this fine? So now you can just take down. When a force acts on a body, it produces acceleration in it. When a force acts on a body, it produces acceleration in it, and the force acting is equal to the product of mass of the body and acceleration produced in it. When a force acts on a body, it produces acceleration in it, and the force is equal to the product of mass of the body and the acceleration produced in it. Got it? So after you have taken down that statement, so you can just take down this. I'll just write down what is necessary for you. F is directly proportional to acceleration produced. F is directly proportional to mass. F is proportional, or F is proportional to mass into acceleration. F equal to some constant into mass into acceleration. If this constant value is experimentally found to be 1, so I get F equal to M. And what is A? A, we might have already discussed in our previous classes. What is acceleration? Change in velocity into time. And this statement that we have, just written is
So clear now.
So if you just take down these statements, F is proportional to A, F is proportional to M. From these two, what do I get? I get F is proportional to mass into acceleration. So I take out proportionality and put equal to, I have to have a constant. And this constant is found experimentally. So what we do is, we find force, we find mass into acceleration, draw a graph. Then I find what is the slope of that graph. That is the constant. So from that, we get F equal to ma, right? Or what is acceleration? Acceleration is final velocity minus initial velocity by time. So here, I hope you're all you know this. What is n? M is the mass of the body. What is shape? A is acceleration produced. K is the constant. K equal to 1, which is the constant. This is K. We call it as proportionality constant. So you're taking it down now. So this F equal to ma. Yeah. Now see, there is one more thing that we have to know. This F equal to ma. F equal to ma is not the exact statement of second law, because there are a few more things that you are required to know to understand the total second law. But for our understanding, we can take this to be the second law till we go to 9th class, right? 9th class, we'll see that there are a few more things. Now, this statement is valid only mass of the body when mass of the body is constant. If mass of the body is not constant, I cannot use this. So in class 8, we'll be only dealing with the situations where mass of the body is constant. I hope it is clear. So here we'll just write down under what condition this is true, when M is constant. So for a system of constant mass. Fine. So if mass of the system is constant, then I can say F equal to mass into